most of it. And what we're looking at here today is going to be a lot of stuff that you already have done, or at least you've seen some of the terminology before. So, ratios and proportions. You guys remember what a ratio was? And you've all seen it. You've all worked with it. Remember what it was? Something. A comparison of what? You're right. Comparison of two things by what? By the two dots. Okay. The comparison is actually, it's technically called a comparison of two things by division. And you're saying by the two dots, that's another way of representing it. So a ratio, thanks. It's a comparison ratio is nothing more than a comparison of two things by division. Let's see what we have. So like 20 girls. It's the easiest thing to do. Yeah, I was kind of thinking. So if you look at it, you want to talk about the ratios of girls to guys. If you say girls to guys, what number goes in the numerator? Girls, and what goes in the denominator? It's that simple. So it would be, your ratio would be 20 to 13, or like you were saying, 20 to 13, or sometimes they'll say this. Those are all been written out ways of writing ratios. I know you have all seen that, but it's not anything too crazy. Guys, come on. One of the other things that you deal with when you're looking at these things called ratios is that since they're going to be fractions, what do you always do to your fractions? Simplify. Reduce is when you're like, trying to shrink something. Like Honey, I Shrunk the Kids. What? So if you're reducing it, so I'm making them smaller like this. See where I'm going with that? So if you have a fraction, let's say it's 10 to 8, when you simplify that, we're not making them smaller, we're simplifying them. We're taking the specific factors out. You always put things in a simplified fraction form. You guys knew that. Also, notice one thing you will never use. Miles, put it away. One thing you will never use. You'll never use a mixed number. Okay? Mixed numbers are bad. Mixed numbers are bad. Mixed numbers are bad. There will be probably one, maybe two times the rest of your high school career in math that you will use a mixed number that makes sense. But in here, it doesn't. Not at all. When you're working with ratios, again, when you simplify them out, this simplified version is called a scale factor. Is the simplified ratio. Okay. Can you just stop talking here, please? You can't handle it, just move away. Wait. Maybe writing something down during second semester would be beneficial as well. So this idea of what's called a scale factor, that will come back a lot as we go along. We start talking about the scale factors of the sides of two figures versus the scale factor of what their areas can be versus what their volumes can be. It's just nothing more than a simplified fraction. Also, what's great, is that when you have this one and you put in there your little fraction bar of 10 and 8, it automatically creates your scale factor for you. So it does the math. We have these. If you don't have one, please make sure you buy one of these because it will otherwise, like yours is giving you decimals. You have to go back and know how to convert everything and go. All right. Fractions, guys. They make your life so much easier throughout so much stuff in math. It's crazy. Okay. You guys have all heard these terms before: scale factor, ratio. So not too worried about it. Don't write this out, but what I want to show you is when we start talking about in terms of geometry, we'll say something. If I want to look at the ratios of the sides, they'll tell you specifically what to look for. They're saying from triangle ABC to triangle DEF. Whenever one comes first, they're talking about a ratio, always goes in the numerator. And then the other one goes in the denominator. It's just, usually it's going to be how you read stuff as you read it from left to right. It's super easy to work with. I just wanted to let you know that's what they do a lot of times in the textbooks. Which then means you can simplify. Now, when you simplify ratios, obviously, if I have 60 miles to 51 miles, what do? Okay? You put it in your calculator, quite literally 60 divided by 51 in the calculator, and it gives you a fraction. And if it's simplifiable, it tells you what the answer is. That's what this stuff does, guys. That's all it is. That calculator would do that for you. You'll have to press a whole bunch of other buttons, go back and forth, simplify back out of the fraction. Do this thing. 60. A lot of buttons. Depixelated, if you will. Anybody else not know how to use their calculator for that? $15, ladies and gentlemen. Wise investment, especially for second semester. Can I compare those two? Why can't I? Yeah, they're not in the same units. And that's the one thing. No, those are M's and C's, not O's. Sorry. Never. Now, one thing when you're talking about ratio stuff, you have to have them the same units. These are metric, and as you guys all know, when you're working metric system, it's just all base 10. Is it easier to work with the smaller units, do you remember, or the larger units? Think about it in inches and feet, if you had something like that. If you had 2 inches, and you had to compare that to 3 feet. Which one of those is easier to convert? Is it easier to convert up or convert down? Down. It's always easier to convert from take the larger unit to make it the smaller. Reason being is that when you multiply stuff, you don't wind up with decimals or other fractions. All right. So if I wanted to put these both into inches, what do you multiply the 3 by? Which gives you how many inches? So this becomes 1/18. Okay. Same idea when you're dealing with centimeters and millimeters. It was what, 7 to 14, I think? Yeah. So if it was 7 to 14, well, how do you convert centimeters to millimeters? It's multiplied by 10. And go from there. Now, when you put that in your calculator, it's going to give you an answer of 5. That's not technically a ratio. No. 1 to 1 would have been like 12 over 12. 5 over 12. And you're on the right track with that. When you write it out, when you're talking about a ratio, and you get just a whole number, 5 in this case, you got to put it over 1. That way you know that there's some sort of comparison there. Am I going to yell and be very, very upset with you if you forget to label these things? As long as you're converting them correctly, you really are. To be honest with you, I usually just use the because I'm a crazy person, I don't really like the metric system. Don't know, I can't approximate metric stuff. I don't know why, it just doesn't make any sense to me. All I know is that in 100 meters, if I'm swimming 100 meters, it takes me about 3 seconds longer than it does to swim 100 yards because it's longer. That's all I know about meters instead of meters versus yards and stuff. I would normally say that any homework, or not homework, but like quizzes and tests, if I switch units on you, it's usually feet, inches, yards, and miles. So those are the only ones that I'm hoping that you guys know. You know how many feet are in all those? All right. 1 foot is how many inches? Okay. 1 yard is how many feet? 1 mile is how many feet? That's all you need to worry about. On any quiz or test, I stick with those. Okay, I stick with those. This isn't chemistry. You don't need to worry about millimeters and centimeters and stuff. No, they don't do chemistry. That's physics, maybe. Whatever. It's not science. Thanks. But yeah, those are the ones that I'm hoping that you guys remember that. Because I'll say, I'll give you like 4 feet, and then I'll give you 3 yards, and you'll have to figure it out. Is that fair? Yeah. The other thing that we will do is this. It's called an extended ratio. An extended ratio means when you have more than 2 things being compared. If it says that the triangle's angle measures are in what's called an extended ratio of 5 to 9 to 16, that means that there's some sort of multiplier to each one of them. And this idea of what's called an extended ratio is going to work for sides. When we talk about perimeter, it's going to work on angles. When we're talking about triangles. We can do these with really any shape because we can get the sum of the interior. We do all that. Excuse me. So if I want to say that the angle measures are in a ratio of 5 to 9 to 16, it is quite literally this. 5 times something, 9 times something, and 16 times something. What do all 3 of those have to have? That's all it is. This is one of the, it looks weird, but it's nothing more than 5x, 9x, 16. Yep, goes right back to a little bit of algebra. So this is real tough. Pace yourself here. 5 plus 9 plus 16. 30. Whew. I know I'm asking a lot here. Which means your value of x is going to be how much? 60. Real quick, it was 60. 60 times 9 is 540. I don't think that's an angle in a triangle. But that's the thing, where if it was multiple choice, if you saw a 60, oops. So be careful. Now here it just says find the measure of the angles. What do you do with that value of 6? You substitute that. So that's 30, 54, 96, I believe. Once again, it's using some definition in algebra to work into a geometry setting. It is relatively straightforward. What's that? Yes. This also works with, get ahead of here, with these definitions as well. The measures of 2 supplementary angles are in a ratio of 1 to 4. What are the measures of the angles? Here you're having to remember what is supplementary. If your angles are supplementary, what do they have to add up to equal? 180. If they're complementary, what do they have to add up to equal? So you're going to use some of the vocabulary that we had from last semester, complementary, supplementary, triangle sum, some parts like that. But by now, that should be like, oh, I remember what that is. So it shouldn't be so bad. But if it's supplementary, that means they add up to 180. If it's 1 to 4, what do I write that as? You're thinking of the ratios, but if I want to figure out what the angle measures are, think about what we just did with the triangles. They were 5 to 9 to 16, 5x, 9x, 16x. Here it's going to be okay. And the only thing that would be different if this said complementary, they'd have to add up to equal how much, right? So whenever you're given this idea of ratios of angles, or later on we talk about ratios of sides, it works the same way. All you're doing is putting those numbers in, throwing a value of x next to them every single time. That doesn't change. It's kind of a nice thing. Divide that out, I think you get 36. You get 36 for one of them, I believe. So if one angle is 36, the other one would be 4 times that, which is again, it's just using some definitions of things that you saw before, supplementary, complementary, stuff along those lines, and now putting it in this idea of using what's called a ratio. Okay. Not too bad. It's a pretty easy thing to start out with. It's kind of nice. Oh yeah, this first chapter, I forgot to tell you this. I think it's only like 5 sections. We should be, I mean, quite literally, we'll probably be done with this by the end of next week. It goes by so. This first chapter goes by real quick. Here, you guys try this one. This is a perimeter one. You guys try this one. It's a perimeter problem where you have the ratios of the sides of 3, 5, and 6. It gives you the perimeter, and then it asks you what's the length of the longest side. When you're running out, yes, to start with. Okay. 3x, 5x, and 6x have to add up to equal 98. Just be careful. Don't accidentally write 180. Because, you know, so let's see, what is that, 14? What'd you guys get for x then? 7? Let's get 7 for x. Now, which one of those side lengths should be the longest one? The 6x. Because there's a 6, and that's bigger than 4. And it's also bigger than 3. In case you didn't know that.
5.
And a 5. Well, it's also bigger than 4. And 1. Again, it's not that it's going to be difficult. It's just don't make a dumb mistake and forget to read something correctly and go through like that. Okay? One more. Like I said, this is pretty easy stuff. You see that? It's 4, 7, and 9 is what it says. 4, 7, and 9 with a perimeter of 60. So let's see, 4x. Sorry. Let's see, 4, 7, and 9 is 20. Still there. So is that going to be 3 or 30? It's a joke. And then it gives you sides then of 12, 21, and 27. Again, freeze. Did a joke and you weren't listening. I know, it's okay. I said, was that 3 or 30? What's the proportion? Remember what that is? That would be a portion. A proportion. You guys have seen this. A proportion is just two ratios. Ratio set equal to ratio. It is. We've actually been using them all along. We just didn't realize that's what we were doing. When you have what's called a proportion, you can do something like this. You have 10 over 8. We said that was 5 over 4. When things are what they call proportional, that means that they're two fractions that are equal to each other. It means that they're what are called cross products. You guys remember that? Cross products when you cross multiply. If you multiply 5 times 8, what do you get? What's 10 times 4? They should be equal. When things are proportional, that means their cross products are equal. So we did this last semester. Remember when I said you can flip things on diagonals? It means the same thing here. 10 over 5 is the same thing as 8 over 4 because they simplify out to be the same. Okay? If I flip it again, I go 4 over 5 is 8 over 10. It still works. When you change things along the diagonals with things that are proportional, those ratios still hold true. And that was one thing I showed you guys that trick from when we did fractions with division for solving for x. How you just change it on the diagonal. It's just a nice little shortcut to look at. So this isn't anything new. It's just one of those quick reminders that when we do the similarity stuff, a lot of the similar triangles and all these rules that we come up with over the course of the next few days, they usually have some proportion to them. And it's a matter of reading the diagrams correctly to set up the equation. And then it's just a quick little process. With that, let's do some problem. I know, it's crazy. Oh no, I hope you remembered how to do math. Give those a shot real quick, then I'll show you guys a shortcut if I didn't know. That's what we're doing adding negatives. Change opposite, which means change the sign. What you're thinking of is maybe divided by a fraction. So if you have 3 divided by a half, it would be 3 divided by 1/2, so 3 times the reciprocal, 3 times 2. That's the thing. We never called that the same change off. That was when we did adding and subtracting. No, it's the same change. Is that big? Yeah. And when you see it, you'd be like, oh yeah, duh. So like I said, this stuff is pretty darn simple. Sure. Okay. You get it? All right. What's that? I'm like, where are you going with this? You know, when you get 3y is 63. Now, there's a nice shortcut if you remembered it. What I'm doing here is just a straight cross multiply and solve for x. When you have fraction equal fraction and there's no like x plus 2 or anything like that thrown into here, which we'll do that here in a minute. When it's just fraction equal fraction, one of the things you can do is, what's 6 times what is 30? 5. So what's 7 times 5? 3 times what is 9? 3. What's 3 times 7? It's a nice shortcut. Do you have to do it that way? No. But if you pick up on it, you recognize the numbers, why not? There's nothing wrong with that. Okay, there's nothing wrong with that at all. The thing I was getting at, though, sometimes you're going to have stuff that you have stuff thrown into it where you can't do that. Okay? Now, this is it's a style question. You will cross multiply like you would. But remember, well, let's see. I know for a fact that, I think there was one. This is usually where you guys make a mistake. Reason being, when you cross multiply this out, you get 3 times the quantity m plus 1. What do you forget to do? You forget to distribute all the parts. Yeah. This is an example of a question that you guys will get wrong. Whenever you have, and I'm being honest because I know. Well, you know, I've been around for a little while. One of the things that's a huge mistake that people make a lot is when you're distributing out, you don't take the 2 seconds to draw those arrows. It sounds silly. It sounds like it's something you don't really need to do. But if you do it, it forces you to remember, okay, knucklehead, don't forget to multiply to the 1. Okay? Happens all the time. I had a question like that in my honors Alpha 2 final where they had to distribute a negative between 2 fractions. And they did it to the first part of the fraction. They forgot to do the second part because they didn't draw it out and distribute the negative. So a lot of people got that question wrong in the final because they didn't take 2 seconds to do that. It's a common mistake. Is it okay to get a fraction for an answer? Absolutely. Is it okay to have a decimal for an answer? Yeah, I would like us to try to stay away from using decimals. There's time and place to use them, but kind of like to try and keep with fractions because they do get a lot easier as we go along. Plus the calculator should be like that for you. Like this is what you were asking a second ago. One of the things that you'll see is that even though this is a fraction, you can still go back and check your answers just by pressing buttons in the calculator. But remember, 3 divided by a fourth, that means 3 divided by 1/4, which is 3 times 4 over 1. So all that reciprocal property stuff still comes back if you go back and check it. I know there's a lot going on there, isn't there? Ah, yes, mathing to math. We know all these. I'm not worried about that. That'll come back later. That'll come back later. Yeah, there's not much left here. I forgot what page this is on, but I had the first couple of them. Let's see, like 4 something, 436, yeah. Work actually get them. I haven't even gotten them yet, so do those for tonight. Give me a second. I have it on. I have the first half or the first chunk of them up on the smart board. I'll put them up there for you guys if you want to take a picture. And go from there. Unless you want to take a picture of the textbook, there's one here too. If you'd like.